Hello, my name is Muhammad Afim Ashraf, and my teammate is Nordania Najwa binti Rosli and Muhammad Akmal Shafiq bin Anwar. We are from Section 1, Semester 1. So we will be presenting uh, a group assignment for subject Numerical Programming BEJ 10201. So my name is Muhammad Afif. I'll be presenting for introduction. So for this project, we are about to explain on how Colpitts oscillator work by designing and simulate the circuit in figure 1 by using software Simulink. So by explaining on how to gain the frequency and incoming voltage output for the circuit at figure 1, we expect the reader could understand the purpose of this project. So what is a Colpitts oscillator circuit? A Colpitts oscillator circuit is a type of LC oscillator, Colpitts, that use a combination of inductor L and capacitor to produce oscillation at a certain frequency. Here. The distinguishing feature of the Colpitts oscillator is that feedback for the active device is taken from voltage divider made of two capacitors in series across the inductor. Also, Colpitts oscillator is the exact opposite of the Hartley oscillator. Just like Hartley oscillator, the twin-tank circuit consists of LC resonance sub-circuit connected between the collector and the base of the single-stage transistor amplifier, producing a sinusoid output waveform. The basic configuration of the Colpitts oscillator resembles that the Hartley oscillator, but the difference this time is the center tapping of the tank subcircuit. This part is a tank subcircuit made at the junction of the capacitor voltage divider network instead of tap auto transformer type inductor as in the Hartley oscillator. Thank you.
Hi, Assalamualaikum. So my name is Nordania Najwa binti Rosli and I will present about method. Methods are the operations defined by a class. Methods can overload MATLAB functions to perform the operations on objects of the class. MATLAB determines which method or function to call based on the dominant argument. Class constructor methods create objects of the class and must follow specific rules. Procedure on how to use Simulink to create and simulate the circuit. So the Simulink is a MATLAB based on the graphical programming environment for modeling, simulating, and analyzing multi-domain dynamical systems. Its primary interface is a graphical block diagramming tool and a customizable set of block libraries. It offers tight integration with the rest of the MATLAB environment and can either drive MATLAB or be scripted from it. Simulink is widely used in automatic control and digital signal processing for multi-domain simulation and model-based design. So the step number 1 is open the MATLAB and type Simulink on the search box. Then click at the blank model to start the design. The step number 2 is click at the library browser and then choose Simscape and then choose the foundation library and click at electrical. The step number 3 is start to design the circuit. Refer to the lab needed. Click at the scenes and then choose display to get the display box, then drag and connect to the voltage sensors for calculate the voltage output. The step number 4 is set the runtime to 0.02 seconds and start run to get the output voltage. Record the value when it shows the value of output. The step number 5 is run the circuit to get the output waveform, then change the direct current voltage to the alternating current voltage. After that, we need to add the current sensor and voltage sensor. Then click at the voltage sensor and choose the value of frequency that need to be measured. Lastly, change the display to scope and connect the current sensor and voltage sensor to the scope. The last step is set the runtime on 0.02 seconds, and after the runtime is changed, then click the Run button and wait until it shows the graph display.
Assalamualaikum, my name is Muhammad Akmal Shafiq bin Anwar. I'm going to discuss about the result. In this project, we designed a Colpit oscillator circuit using MATLAB simulating software as shown in figure 1. And then, we run the simulation using sampling time 0.02 seconds. If you look here, this is our circuit. And then, when we run the circuit, we look at the graph. It shown the Colpit oscillation wave. So the wave that are shown in graph display is using sample time 0.02 second and stop time 0.02 second. And this is the wave that have been zoomed to make it clear to see. The wave are like this. So we can get the frequency on the graph. The frequency that we got from figure 1 simulation are 10.875 kilohertz. This is our figure 1 circuit. We use the time circuit 24 nanofarad on C1 and on C2 240 nanofarad, and on the inductor 10 millihenry. We use stop time 0.02 second and then we run. We will get this graph, this wave, and the output that we got 10.859 kilohertz. For the question B, referring to figure 1, discuss on the output voltage calculated by the MATLAB simulating software. So we use this display meter to check the output voltage. We got the output voltage 7.493. The discussion are the voltage feedback to the transistor is obtained across the capacitor C2, which means the feedback signal is out of phase with the voltage at the transistor by 180 degrees. This is due to the fact that the voltage developed across the capacitor C1 and C2 are opposite in polarity as the point where they join is grounded. For question D, we designed a Colpit oscillator circuit to produce a low oscillation frequency. In this circuit, we designed the Colpit oscillator to produce a low oscillation frequency. To make the circuit produce low oscillation frequency, we changed the value of capacitor C1, C2, and inductor on the tank circuit. We changed the value of the capacitor C1 to 0.44 microfarad. Then we change the value of capacitor C2 to 9.56 microfarad. Lastly, we change the value of the inductor to 3.71 millihenry. As you can see here, this is the tank circuit that we change the value. This is C1, this is C2, and this is the inductor. So the wave that we got from that low oscillation circuit using 0.02 second stop time, we got this wave on the graph. And when we use the 2-second stop time, the low oscillation frequency wave will be look like this. The frequency that we got from the low oscillation frequency circuit are 4.1 kilohertz. This is our low circuit Colpit oscillation. It produces low oscillation frequency. As you can see here, in this circuit, we change the value of the component on the tank circuit, we change the C1 to 0.44 microfarad, C2 to 9.56 microfarad, and then the inductor we change it into 3.71 millihenry. When we run, the output waveform of the frequency that we got are like this. As you can see, the output frequency that we got are 4.099 kilohertz. The comparison on high and low frequency are on the output 10 kilohertz. It's more efficient because it produces more frequency. On the output 4 kilohertz, it's less efficient because it produces less frequency. The output 10 kilohertz can regulate 3 volt until 22 volt because it produces more frequency. On the output 4 kilohertz, it cannot regulate because in the end it will be less frequency. On the output 10 kilohertz, it becomes cold-pitch endless and can be regulated. On the output 4 kilohertz, it reduces the frequency response until eliminate cold-pitch structure and fast constant on 12 volt only.
Okay, thank you, my teammate. So my name is Muhammad Afif. I'll be explaining on discussion. So on discussion, I will be answering a question from the group assignment question, which is how do you determine the oscillation frequency for this Colby oscillator? To find the frequency of the Colby oscillator, we use this formula: Fr equal to 1 over 2 pi square LCT. This is a main formula, but before we use this formula, we need to find the value of CT. CT is represented as a C total, which is C1, and C2 is parallel, so we use this formula. So for step 1, we need to find CT. So C1 we know is 24 nano, C2 is 240 nano, so we start the value here, and we get this value. C total equal to 21.82 nanofarad. So for step 2, we need to find the frequency. We refer this formula back, and we subtract all the value L and CT in the figure 1. So after that, we get the answer, which is 10.8 kilohertz. So the frequency in the graph should be near from this value, from this actual calculation. So this frequency of the Colby oscillator in figure 1 is 10.8 kilohertz. This is the actual value, but in the circuit, the frequency should be near from this answer, this frequency. So for this part, based on question D, we need to produce a low oscillation frequency. To get what is meant by low oscillation frequency, it is mean that the frequency from here should be lower than this figure 1 frequency. So we decide to change the value of inductor C1 and C2. capacitor 1, capacitor 2. So to calculate the frequency for low oscillation frequency, we use the same formula as this part. Find the CT, and then we get this value, and we set the value of frequency, and we get this value for frequency for this oscillation, for low oscillation frequency. Fr is equal 4.029 kilohertz. So the frequency that we get from the output should be near from this calculation. Thank you.
In the conclusion, we have to use a MATLAB software to complete the task based on the task given. We need to make a circuit simulation and get the waveform from the circuit. Then we obtain this circuit using this software and have tested the simulation and get the output waveform. Then we use the Simulink and add on product to MATLAB. A Simulink function is a computational unit that calculates a set of outputs when provided with a set of inputs. Lastly, the Simulink is integrated with MATLAB software and data can be easily shared between the programs.